Say hello to the Atmospheric Water Extractor, or simply put, the AH. It is the only renewable water production system able to produce hundreds of millions of gallons of water per unit per year and can be placed anywhere, operating 24 hours a day, 7 days a week. Here is a cursory look into the inner workings of the AH. The wind capture panels are attached to the upper tower. Housed on the main rotating structure are the airflow amplification systems, which incorporates Venturi impulse force exhaust thrust. The wind capture panels accommodate wind force and reduce drag. The flutter vane modules were designed to collect compressed air in winds less than 2 miles per hour. The external propellers connected to air compressors add additional thrust and controls overall speed. All wind capture elements are mounted on the rotating drive shaft. Descending down the tower from the drive shaft, we connect to the rotating main flywheel, which is the predominant torque power source linked to the compressor modules. There are 3 main sets of compressor modules: the flutter vane compressors, the air scoop propeller-driven compressors, and the main flywheel-driven compressors. Encircling the tower and attached to the compressors is the air intake ducting, supplying cooled dewatered intake air to an assembly of compressors. Here is a closer look at one of several large air compressors attached to the main flywheel. A key benefit of this device is the CO2 extraction system, or carbon scrubber, designed to remove CO2 from the captured air. Compressed air is transferred to the circulating heat exchanger. It increases the density of the air being stored and reheats the released air to run air motors which engage the generators. Working pressure energy is stored in the low-pressure tanks. High-pressure tanks store the bulk energy. Although the AH is a massive utility-scale water production and delivery system, as an upgrade, electric generators can be connected to the system in order to produce utility-scale renewable energy as well. This unique AH unit has the ability to be modified to become a water and power production system if needed. This option allows it to be connected to electrical power users almost anywhere and can be a valuable renewable energy source for distributed power generation. AH installation sites allow interconnection to existing utility distribution lines, even in urban settings. This will provide a distributed generation of power. One of the most important components of the AH are its forced rotation modules. This unique feature uses less than 5% of the stored compressed air to apply force to the drive shaft, thereby causing rotation to continue during no wind conditions for up to 14 days and to supplement rotation during light wind periods. This system uses cold decompressed air to chill the liquid in the condenser circulating system to below dew point. This function filters out airborne particulates as part of the treatment process. The water vapor condenser condenses the water vapor into a liquid water by reducing the temperature of the air below dew point. The water treatment modules ensure that any airborne bacteria or organisms are killed, creating potable water. After being treated, the now potable water is temporarily stored in these tanks. When utility-scale production of water is needed, massive quantities of water can be piped to multiple distribution facilities. It can furnish major land irrigation, and it can provide reservoir, aquifer, and lake refilling on a colossal scale. Well, there you have it. The amazing Atmospheric Water Extractor is a cost-saving, reliable, and completely renewable water generator, each unit providing millions of gallons of water 24/7, 365 days a year.